Okay, students, if I have not muted anybody, if you have any problem, you can ask me. So, this is the actually continuation of my previous lecture. So, let me tell you what happened in the last lecture. In the last lecture, I told about dielectrics, and the topic for today is polarization of dielectrics. We have confirmed in the previous lecture that the dielectrics are of two types. One are nonpolar and other are polar. So in the nonpolar molecules, dipole moment of each molecule is 0, and in polar molecules, dipole moment of each molecule is not 0. This is at atomic or molecular level. But at macroscopic scale, the dipole moment is 0 for full sample, whether it is polar or it is non-polar. This is something that we have discussed previously, and our lecture time was over when I was discussing that. So in case of polar molecule, the sample contains a large number of dipoles, and these dipoles are randomly oriented. So in the absence of external electric field, the net dipole moment of the sample is 0. So what will happen? Let polar sample is placed in external electric field. When the polar sample is placed in external electric field, then we can, let us say this is the external electric field. Then you know that every dipole experiences torque in external electric field, and the vector form of torque is P vector dot E vector, where E vector here is the net electric field. Please remember, E vector is the net electric field on dipole. The magnitude of this torque is given by P E sine theta. You know this. And for theta is equal to 0 degree, we called that dipoles are in stable equilibrium. For theta is equal to 180 degree, we call it to be unstable equilibrium. And for theta is equal to 90 degree, we call it to neutral equilibrium. These are the things I guess you have already studied in school physics. But please remember, this E electric field will be different from applied electric field. So why is it so? Why? Why the electric field on a dipole is different from applied electric field? So the answer to this question is, each dipole is itself a source of electric field. So we know that if this is a dipole, we have found the expression for electric field on the axial line We found this expression in school physics. Then we have also found the electric field on equatorial line. And then we have also found the electric field due to a dipole at any general point. And at all these three places, the electric field existed. So out of these dipoles which are in the sample, every dipole is a source of electric field. And now we have two fields. Suppose there is one dipole. If I put a round over here, then this dipole is this one. So this dipole will not feel the applied electric field is ext, but it will not feel electric field ext. Ext is applied electric field, but it will feel some electric field, let us say E vector. And what will be E vector? It is net electric field. It will be vector sum of applied electric field plus local electric field. Local electric field is the electric field generated by these dipoles which are in the nearest neighbor, like these. These dipoles are in the nearest neighbor of this dipole. So these dipoles will produce electric field, as I have already told you, and the combined effect of these will produce some electric field called local electric field, and that local electric field will add in the applied electric field. It may be in the direction, it may be opposite to the direction, it may be at 30 degree, 40 degree, any angle, depending upon what is the net result of these dipoles electric fields. So as a result, it will not feel the electric field whichever is applied. So from here we conclude one thing, that when we apply external electric field to a polar dielectric, then I can draw a statement. I would change the color of the text for this statement because it is an important statement, so that you can see it from a distance. All dipoles in polar dielectric experience different electric field in general. Different electric field in general, although applied electric field is same for all, and that was EEXT. So is it clear? If it is okay, then someone amongst you can unmute himself or herself and say it is okay, so that I will move to next page. Is it okay?
Yes, sir.
Okay, then I will move to the next
Okay,
page.
sir.
Okay, very good. So I will
Sir,
now
please explain E-local.
e-local.
सर जो
Haji, please.
Sir, please explain E-local.
I will explain. There was somebody else who tried to ask something. Please.
सर जो डाइपोल का अपना इलेक्ट्रिक फील्ड है वो भी हम ई लोकल में गिनेंगे
हाँ हाँ वही तो है, ई लोकल इलेक्ट्रिक फील्ड है. फॉर एग्जाम्पल आई विल टेक एन एग्जाम्पल फ्रॉम दिस क्लास इट सेल्फ. आई एम स्पीकिंग, what I am speaking, I am talking about dielectrics. Is it okay? Now in this class of this is a class of how many participants are there? This is a class of 76 persons. So my question to you is, please give the answer carefully. My question to you is, will you listen whatever I am speaking or something different? Give me the answer. Whatever I am speaking, will you get the same thing or you will get the different thing?
Same thing.
You will get the same thing only if other persons are listening. And you see that when our lecture started, two or three persons they were speaking also. Is it okay? When they were speaking, it means they were producing their own sound. Is it okay? So you will not listen whatever I am speaking. You are affected by your locality. You are affected by my sound as well as locality. So the local effect will definitely produce some problem in your understanding of the physics. If they all start muting themselves, then they will become non-polar. Then whatever I am speaking, you will start listening. Similarly, all dipoles are polar because they are themselves a source of electric field. Two questions asked me the question. The answer to the both of questions is the same. What is local electric field? Local electric field is the electric field produced by dipoles, other molecules, dipoles or other molecules which are surrounding the given molecule. The given molecule means the molecule under study. Is the answer clear? Local electric field is the electric field produced by the dipoles surrounding the given dipole. Is the answer clear? Should I move to next
हेलो
page?
हेलो
Yes.
सर।
हाँ जी बोलिए.
सर आपने से वो टॉर्क जो बताया सर उसमें जो बताया थीटा इक्वल टू 180 डिग्री तो वो अनस्टेबल हो जाएगा और
हाँ.
थीटा इक्वल टू 90 डिग्री वो न्यूट्रल हो जाएगा। सर वो सब समझ में नहीं आ रही कैसे होगा।
Okay. Should I explain it for everybody? It is actually a concept which you have studied in plus 2 class. I have to move
प्लस
away
टू ਚ
from.
ਪੜਿਆ ਹੋਇਆ ਹੈ
I have to
ਸਰ।
move.
ਐਰੋ ਦੇ ਨਾਲ ਕੀ ਉੱਪਰ ਕੀ ਲਿਖਿਆ ਹੈ?
ਕਿਦੇ
ਐਸ ਤੋਂ ਐਰੋ ਤੇ ਉੱਪਰ ਵਾਲੀ ਫਿਗਰ ਤੇ
ਉੱਪਰ ਵਾਲੀ ਜਗ੍ਹਾ ਤੇ ਟੌਪ ਤੇ ਬੇਟਾ ਮੈਨੂੰ ਨਹੀਂ ਸਮਝ ਲੱਗੀ ਐਰੋ ਦੇ ਨਾਲ ਐਸ ਕਿੱਥੇ ਲਿਖਿਆ ਪੀ ਐਸ ਇਜ਼ ਇਕੁਅਲ ਟੂ ਬੇਟਾ ਪੀ ਐਸ ਆ ਪੀ ਸਟੈਂਡਸ ਫॉर ਡਾਈਪੋਲ ਮੋਮੈਂਟ ਉਹ ਪੀ ਸਹੀ ਨਹੀਂ ਬਣਿਆ
ਸਰ
ਹੋਇਆ
ਉਸ ਤੋਂ ਉੱਪਰ ਜਿਹੜਾ ਐਰੋ ਦੇ ਨਾਲ ਲਿਖਿਆ ਹੋਇਆ ਹੈ ਨਾ
ਇੱਕ ਮਿੰਟ
ਐ ਤੁਸੀਂ ਐਰੋ
ਇਹ ਇੱਕ ਆਹ ਵਾਲਾ
ਇੱਧਰ ਨਹੀਂ ਇੱਧਰ ਰਾਈਟ ਹੈਂਡ ਸਾਈਡ
ਰਾਈਟ ਹੈਂਡ ਸਾਈਡ ਆਹ ਪੀ ਐਸ ਆਹ ਐਸ
ਫਿਗਰ ਤੇ ਸਰ ਹਾਂਜੀ ਹਾਂਜੀ
ਇਹ ਸੋਰਸ ਆ ਸੋਰਸ ਆਫ ਇਲੈਕਟ੍ਰਿਕ ਫੀਲਡ
ਓਕੇ
dipole
ਓਕੇ
itself is a source of electric field.
ਹਾਂਜੀ
Okay, so for those persons who do not know what is stable and unstable equilibrium, I will just tell them about this structure, but it is a general concept. Please do not take it in the dipole moment. I would take the example of mechanics. So suppose we have a cone like this and there is a ball here. We have a cone like this and there is a ball here. Please remember, ball here is not moving, ball here is also not moving. Both of these are in equilibrium. Will you agree? At least that student should speak yes. जिसने ये क्वेश्चन पूछा था.
यस
Is it
यस
okay?
सर।
These will be in equilibrium.
या
But what do you think now? I move this ball, I disturb this ball from
हेलो
here.
सर
I disturb this ball from here to here.
What now?
When I will release it, it will come back here again. So this is the property of stable equilibrium. Stable equilibrium is that to which the system returns back after the disturbance effect is over. But unstable equilibrium is that if we create a disturbance in it, it will never return here. For example, if you disturb this ball, you just put a small push to this ball. But when you push to this ball will come here and here and here, but it will never go back. So such kind of equilibrium is called unstable equilibrium. And in case of neutral equilibrium, it is just like a flat floor. You put the ball here, you push here, it will come here, you push here, it will come here. It is happy at every place. Such a position is called neutral equilibrium. It has no tendency to go anywhere. Is the question answered?
यस सर।
Okay, now in case of a dipole, when you have theta is equal to 0 degree, then what will happen? The potential energy, you know that it was minus Pe cos theta, and potential energy will be minimum, minus Pe, it will be minimum. So the dipole will prefer to remain in this position forever. forever. So such a condition will always be called as stable equilibrium. I would request all of you to mute themselves if you are not asking any question. Okay, so in case theta is equal to 180 degree, the equilibrium will be, therefore,
Maximum
potential energy will be maximum, and maximum potential energy gives us unstability. So
instability.
dipole is there. It is because the torque is zero, because sine 180 is also zero. But if somebody disturbs it even slightly, it will never return back here. So that is why 180 degree is unstable equilibrium. 14 students want to ask the question. Please ask the question. Sir, please repeat whatever you have taught now. I have joined just now. Sir, repeat whatever you have taught now. Ankit Kumar. Sir, please repeat. I have just joined now. Ankit Kumar, I have just given this part. It was recapitulation. Have already discussed in my previous lecture and the time was over by then. So I told that when we apply torque on a dipole, it experiences torque. When we apply electric field on a dipole, it experiences torque. The formula for torque is this. Magnitude of torque is given by this formula. And I told you that three situations are there. Theta is equal to 0, 180 and 90 degree. So, and I told that it is stable equilibrium, unstable equilibrium, neutral equilibrium. And I told in my this discussion so far that a dipole does not experience the electric field that is applied. It experiences electric field different than the applied electric field because of the effect of the dipoles surrounding a given dipole, that is called local electric field. So all the dipoles in the sample do not experience the same effect of electric field. This is what I have taught so far. Okay, let me now go to my this page. So therefore kindly remember, if I apply external electric field EEXT, then in the sample most of the dipoles will be in the direction of applied electric field, but not all. So in case of non-polar, when we apply external electric field, then by applying external electric field, all dipoles immediately come in the direction of electric field because the molecules were non-polar. So what is the cause of polarization? So cause of polarization in case of polar dielectrics, it is the orientation. You are rotating the dipoles. This is also called due to torque. And in this case, it is due to polarization is due to induction. Because dipole moment is zero, no dipole can feel the torque. So only the molecules are getting enlarged. Center of positive and negative charges are going away from each other because of this.
सर एक बार रिपीट करो थोड़ी आवाज सही नहीं आ रही थी सर
Now it is okay.
नेटवर्क इशू
Now it is
जी
okay.
सर हुन ठीक है पहले सही नहीं आ
I will repeat. Now I have discussed the polarization of polar as well as non-polar dielectrics. I am saying in case of polar dielectrics, it is not
So your
necessary.
voice is breaking.
Okay, voice is breaking. Then kindly stop for a while. I will switch my internet connection. Okay, wait for a minute. I hope now you can see the whiteboard.
Yes,
जेड़ा
sir.
पीछे सीगा सर E net equals to E external plus E local, so
Hmm.
जेड़ी E local है वो opposite direction जो होगी ना E
No, no,
external
no, 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 no. It depends upon, for example, now think about this. It depends upon how many surrounding dipoles are in the direction of applied electric field.
अच्छा सर
Okay, so the behavior of local electric field will change from place to place.
सर for example
No, let me see this. Sure, I will go to the back page. Okay, now look at this dipole. Rather, I will take an example. So this page is empty. I will use. So suppose I have a this dipole. This dipole is understudy. Okay, so now I will change the pen color. These are the dipoles which are local around it. So these are randomly oriented dipoles, and this is the external electric field. This is situation number one. Now, then this is situation number two. This is the dipole under study. So these are the local dipoles. Please tell me what will be the overall effect of these dipoles toward the direction or away from the direction in situation number one. These dipoles which I have written by black color.
Toward.
Toward the direction.
And what will be the
Sir, away
overall
from the direction.
because most of them are making acute angle with the applied electric field. That the
Yes.
reason is this. Okay. Now
Yes.
here the external electric field is this. Now what will be the
Disagree.
overall behavior of these?
Away
Sir,
from the
opposite.
away
direction of the
from
electric
the
field.
Away from.
I guess now you got the answer. Okay.
Yes, sir.
ठीक है ना? Should I move to the next page?
yes
So
Yes, sir.
I was telling you that in case of this, the cause of polarization is orientation or torque, and in this case, the cause of polarization is induction or the force. Force and torque are different things. Force can be applied to neutral bodies also,
so
and
both materials same
materials. No, no. This is a polar dielectric, beta.
सर लिख
This is a non-polar dielectric.
जी
I supposed that you have attended my previous lecture. That is why I did not write.
ਯੈਸ ਸਰ ਅਟੈਂਡ ਕੀਤਾ ਸੀਗਾ ਤੁਸੀਂ ਅੰਦਰ ਨੋਨ ਪੋਲਰ ਦੇ ਬਾਰੇ ਪੋਲਰਾਈਜੇਸ਼ਨ ਦੱਸੀ ਸੀਗੀ
हाँ, but there is a representation also, na. Non-polar molecule is written by sphere or
ਯੈਸ
oval.
ਸਰ ਯੈਸ ਸਰ
Sphere when center of positive and negative charge are the same, and oval when we apply the electric field. And
indeed
polar molecule is also shown by arrow. That is why I did not write. Is it okay now?
yes sir
Okay, then please remember, when you apply the electric field, you see that torque is equal to P E sine theta. It depends upon two things. One is sine theta, second is E, because P for every dipole is constant. So first of all, we must have more dipoles in the direction of electric field. If it is not the case, then how can you increase the torque? Then you increase the electric field. So if I increase the electric field, then these dipoles which are still not in the direction of electric field, look at this dipole and this dipole, these are making some angle. This is the direction of applied electric field, this is the direction of the dipole moment, there is some angle between them. So I want to bring this dipole from here to here, this direction. But can I do? I can increase electric field now. So as you go on increasing electric field, a situation will reach when all dipoles will be in the direction of applied electric field. That situation, when it comes, then the material is said to possess saturation polarization. You might have studied this sentence in your school physics. Saturation polarization.
yes sir
This is the maximum dipole that a material can show.
yes
Is it okay?
yes sir
Okay,
Yes,
now
sir.
saturated point
Yes,
ਹੁੰਦਾ
sir.
yes,
saturated point ਹੁੰਦਾ ਇੱਕ
yes, that saturation hasn't been achieved.
yes
Is it okay? Now, there is one thing that your teachers taught you in your school physics. Actually, that point is the crux of today's lecture. In your school physics, your teachers said this plus is in contact with this minus. This plus is in contact with this minus. So these plus and minus centers of charges will cancel each other's effect. So in general, bound charge will not be produced, yes, within the volume of the material. Bound charge will be produced only at the surface. This negative charge, negative charge, negative charge, negative charge. Kindly confirm that. Your teachers
yes
taught
sir
you like this. They said when a material is placed in external electric field, then the bound charges are produced on the surface of the dielectric. Is it okay?
ਹਾਂਜੀ sir
Okay,
yes sir
but be careful. This statement is valid only for non-polar dielectrics. So, if multiple choice questions come in your syllabus and it is asked from you whether the bound charges produce on the surface or bulk or volume or both of them, the correct answer is both of them. Is it okay? If I show this by arrow, let us say, what is the dipole direction? It is from center of negative charge to positive charge. If I show this by arrow, now it can be shown by arrow because it has been polarized because of electric field. If I show this by arrow, if I show this by arrow, either you can say positive is coinciding with negative, or you can say head of the previous vector is coinciding with the tail of the next vector. But what will happen in case of polar molecules? It is not necessary. Look at this. This is the head of one dipole, and look at this. This is the tail of the second dipole. Are these in contact with each other?
No, sir.
no sir
If these are not in contact with each other, can they cancel out?
No, sir.
No,
Answer
sir.
is yes or no. Most of the
No.
students
Maybe.
sir
maybe.
yes they,
Correct answer is may or may not be. So
yes sir
what is
sir
the
if it is in the totally opposite direction they can cancel it other
yes, yes,
if not
look at this. Maximum polarization के केस में ये true हो जाएगा. That was saturation polarization. It will be true in case of saturation polarization. But saturation polarization is an extreme case. It is not always met. It is not a general case. This is the general case. So in general, when a dielectric is placed between the plates of a capacitor, and if it is not non-polar, let us say it is a mixture of polar as well as non-polar, then what happens? Let me add a new page. Okay, then what happens when I would use the word heterogeneous? When heterogeneous dielectric is placed in external electric field, then bound charges are produced on the surface as well as within the volume of the body. So, because of this, the induced charge density will be volume charge density. This is the main difference. So, you have studied in school physics polarization of homogeneous and non-polar dielectric. I am discussing with you heterogeneous, which is a mixture of polar as well as non-polar molecule. In this case, charges were produced on the surface only. Here the charges are produced on the surface as well as in the bulk. The charge density there you wrote in your school physics was it was sigma p. So I will use charge density here as rho p. There you used a vector that was called polarization vector. Its symbol was capital P, and it was defined by you as a dipole moment per unit volume. I guess you know this formula, this vector, this quantity, and you proved in your plus 2 class that capital P and sigma p are same in magnitude, and in vector form it was given by capital P is equal to sigma p into n cap, where n cap is a normal vector. It is a unit vector normal to the surface of dielectric. It is a unit vector normal to dielectric surface. This is something you have studied in your school physics, but this is only for non-polar. In general, here the situation is different. Our volume charge density must be talked instead of surface charge density. Therefore, I would write here for you that actual relation is this was only for school physics. It is valid only up to school physics. For non-polar dielectric, it is still valid. But for a heterogeneous, the relation is given by rho p is equal to minus del vector dot p vector. What is this? It is the negative of divergence of polarization vector. And this is the correct formula. which is applicable everywhere. For a non-polar, this formula will automatically change into this formula. For a polar, this is always there. So if you have any question up to this point, you can ask me. Otherwise, I will start proving Gauss law for dielectrics. This was our ultimate aim. I would have to progress up to this point. If you have a question, you can ask. Otherwise, I will move to the next page.
सर चार्ज डेंसिटी इक्वल टू रो पी कैसे हो गया?
रो पी नहीं है, कहाँ पे ये?
सिग्मा पी है सर.
हाँ, सिग्मा पी। ये तो प्लस टू में आपको के टीचरों ने आपको कराया होगा. द योर स्कूल टीचर्स माइट हैव प्रूव्ड इट इन द प्लस टू क्लास. डिड
सर ये
नॉट.
लास्ट में जो एक्चुअल रिलेशन निकाले है डेल पी वो समझा दो थोड़ा सा फिर से.
You have to remember it. I will not prove it. You have to remember it. I did not prove this. I have not proved this because it will go beyond the discussion. If you want the proof of this relation, then give me separate time. I will prove it by taking 1 hour. It is a separate article. I do not, for your BTech syllabus, I do not need it.
Excuse me, sir.
Just raise your requirement. If you wish, I will prove it for you. I will not prove it for
सर बस
class.
रिकॉल करा दो.
Huh? Yes, this was never taught to you in physics class, in school physics. This was taught to you. What was taught to you? That it was the dielectric was of cubic shape,
बढ़िया है ये वाला.
like this.
Right hand side.
Right hand side you have studied. You know that it was, let us say, the width of the dielectric is small d. The total induced charge is minus qp. Total induced positive charge is plus qp. Then the dipole moment, total dipole moment was either charge into distance between charges. It was qp into d. And polarization vector is the dipole moment divided by volume. And if I write it like this, qp into d divided by volume is, let us say this area is a. The volume will be area into width. It will be a into d. D and d will get cancelled. This is now charge upon area. It will be simply equal to sigma p. So this is easy to prove. That is why I have proved it. But this is not easy to prove. I need 1 hour discussion to prove it. I can prove it, of course, but I will not prove it in the class. Because as per syllabus, this relation is not in our syllabus mental. It will go beyond the discussion.
Excuse me,
If
sir.
somebody is singly interested, that person can send me WhatsApp message, then I can arrange a separate lecture for that person only.
Excuse me, sir.
Yes.
सर जो नॉन पोलर की जो डाइलेक्ट्रिक होगी उसमें फिर कौन सा हम फॉर्मूला यूज करेंगे?
This is a particular formula for non-polar.
यस सर.
In
सर
there,
लेफ्ट वाला नहीं यूज कर सकते?
left वाला कर सकते. It will change here, है ना? For a
Okay.
non-polar, this formula, for a non-polar, you can change this formula to this.
ये यूनिवर्सल है ना, फिर किसी के भी यूज हो सकता है.
This is applicable for polar as well as non-polar.
Okay, sir.
This expression on the right hand side is a special case of the expression on the left hand side. This is a bigger expression. This is a general expression. This is a special expression.
Yes, sir. Thank you.
Any other question? So this is over. Now I will start with you the topic for today's discussion, and its name is Gauss law for dielectrics. This is actually the real Maxwell equation. The one you have studied in the previous lecture for Gauss law for vacuum is again a special Maxwell equation. It was not general Maxwell equation. So Gauss law for dielectrics is the main equation. Gauss law for dielectrics. So now suppose this surface, this is a closed surface. In the previous discussion, this closed surface was containing only charges which we want to discuss. Now, let us say there are charges. Suppose you can think previously there were charges. Let us say these were iron particles. In the previous part, whenever Nandini madam, your another physics teacher, she proved that differential form of Gauss law. So then these were the charges. Some of them might be positive, some of them might be negative. So these charges are actually are the particles. Okay. So now you place some, let us say this space is now filled with water. This dotted region is water, let us say. Now this is a closed surface. It contains free charged particles. Let us say these are charged iron fillings. Uh, can you hear my sound?
Yes,
Yes,
sir.
sir.
Okay, so these are charged iron particles. So the charge contained by them is called free charge. Now I have filled this whole space with water. Now water is what? It is a polar dielectric. Now, what will happen? This free charge, you know, every charge, if it is positive, it is a source of electric field. It emits free electric field lines away from it. And if it is a negatively charged particle, it is a sink for electric field. The field lines will converge to that point. So, this water molecule, these water molecules, these will get polarized because of these iron particles which are having any charge. We have charged them, then put in the water. After charging them, these iron particles are put in the water. So this surface contains a medium. That medium has a dielectric constant K. Its permittivity is epsilon, and this medium contains some free charge QF. So the free charge is given by, you know, that dq upon dv is equal to rho, and I can write dq is equal to rho dv, and therefore q is equal to triple integration of rho dv. So this is a general expression for total charge. Now the charge in this surface are of two types. One is the free charge. So if I use this equation star, for the free charge, what are the total charge on these iron particles which are filled in water, then total free charge will be triple integration of volume charge density of free charges and the volume. Please remember, this volume is same for water and this volume is same for iron fillings. So iron fillings are present everywhere, water is present everywhere. So iron fillings create free charge and water is the medium. And what will be polarized charge? This is the charge that is produced by water due to polarization. This is the charge that is due to iron fillings. It is free charge. Now, according to expression star, I can write this also again by rho p dv. Is it okay? Now, according to Gauss law, double integration over closed surface E dot ds is 1 of epsilon naught times the net charge enclosed. So this equation will become now 1 over epsilon naught times the net charge is actually the sum of two charges, free charge and the polarized charge. Is it clear up to this point? I have to shift to new page.
Yes, sir.
Is it okay? For polar dielectrics and non-polar dielectrics, the net charge is not the applied charge. Net charge is the applied charge plus induced charge. Okay, this equation will become now double integration E dot ds is equal to, it was 1 upon epsilon naught. I am repeating it for you. It was qf plus qp. Now I am going to put the value 1 upon epsilon naught. Qf is actually triple integration rho dv plus, this is a triple integration rho p dv. This is rho f dv. Now I can apply Gauss divergence theorem. I have already taught you. If I apply Gauss divergence theorem on left hand side, then this quantity will become equal to del dot v e, sorry, not v, del dot e dv triple integration, and right hand side is 1 pi epsilon naught, and this is triple integration rho f dv plus this quantity. If I show my previous page, rho p, then I have to go to the even previous page. Now you can see this rho p is given by this expression. Let me change the color of the pen. This rho p is equal to the negative of divergence of a polarization. So therefore, let me go to the next page. This toolbar is disturbing me. Okay, so I can write here, it will be minus of triple integration of del vector dot capital P vector and dv. Now I can take all these quantities on the left hand side. This epsilon naught is now cross multiplied, it will come here. So it will become triple integration epsilon naught del dot E plus triple integration del dot P minus triple integration rho f dv equal to 0. I can take this epsilon naught inside, and this volume integration is taken common, because we know that volume integration is distributive. So I can write here triple integration, this will become del vector dot, instead of E I can write round bracket epsilon 0 E. I can very easily take epsilon 0 inside because it is a constant quantity, and here I can take del vector common. Look, this is del dot P, this is del dot something, I have taken del dot common, then it will become plus P vector minus rho f and dv, and this will be equal to 0. I can put here round bracket because volume integration has been taken as common. Let us define a new vector capital D is equal to epsilon 0 capital E plus capital P as displacement vector. This vector is called a displacement vector. So please remember, this is my ad hoc assumption. Just to make the expression simpler, I have chosen this as a new vector, and I call it to be displacement vector. So then this equation number 2, it will simplify like this: triple integration del dot capital D minus rho f and dv is equal to 0. Now this is equation 3. I would make a same statement that I have made 2 or 3 times earlier, that this relation is valid for any arbitrary closed surface. What would have happened? Let me show you the main page.
डाइवर्जन ए ਦੇ ਨਾਲ ਡੀਵੀ ਕਿੱਧਰ ਗਿਆ ਸਰ?
कहाँ पे?
सर थर्ड लास्ट लाइन।
हाँ, this is a mistake. Thank you, please. Always point out my mistakes that I can make while giving these kind of lectures. It was correct. I think okay, it was there. I would have to put it like this. No.
एप्सिलॉन नॉट तो पहले पा दो।
No, you were correct. I would write here. In fact, I have to write here also.
यस सर।
This I will erase. I guess now it is okay. Is it okay now? Now I was showing this. Now you can see this is a arbitrary surface. This is an arbitrary surface. I could have drawn this surface to be smaller, or I could have taken a surface of this much size or this much shape. What is the difference if I change my surface from here to here, or if I change my surface from here to here? I am changing the size and shape of the surface. This is equivalent to changing the, yes, limits of integration, because this volume integration, this is a volume integration. Please remember, this volume integration will cover the whole volume of the body. Obviously, if its body is small, then the volume integration limits will be closer to each other. If volume is large, then the volume integration limits will be away from each other. So therefore I can say this relation is valid for any arbitrary surface, and it is independent of the limits of integration. Therefore integrand itself has to be 0. Integrand has to be 0. So if integrand has to be 0, then I have to add a new page. Then I can say del dot capital D minus rho f has to be 0, which will mean del vector dot capital D vector must be equal to rho f. This is the differential form of, this is differential form of Gauss law for dielectrics.
ਐਕਸਕਿਊਜ਼ ਮੀ ਸਰ।
Yes, please.
ਸਰ ਇਹ ਇਦਾਂ ਜਿਹੜਾ ਸੇਮ ਰਿਲੇਸ਼ਨ ਹੈ ਇਦਾਂ ਸਰ ਥਰਡ ਲਾਅ 'ਚ ਵੀ ਹੋਇਆ, ਉਹਦੇ ਵਿੱਚ ਵੀ ਸਰ ਜਿਹੜਾ ਇਹ ਸਰਫੇਸ ਏਰੀਆ ਸੀ ਸਰ ਉਹ ਵੈਨਿਸ਼ ਕਰ ਗਿਆ ਸੀ, ਮੈਡਮ ਕਹਿੰਦੇ ਜਿਹੜਾ ਇੰਟੀਗ੍ਰੇਸ਼ਨ ਹੀ ਉਹ ਸਰਫੇਸ ਏਰੀਆ ਦੀ ਮੈਮ ਕਹਿੰਦੇ ਉਹ ਵੈਨਿਸ਼ ਹੋ ਜਾਂਦੀ ਆ, ਉਹ ਟਾਈਮ ਦੇ ਵਿਦ ਰਿਸਪੈਕਟ ਟੂ ਚੇਂਜ ਨਹੀਂ ਕਰਦਾ ਜਦੋਂ ਸਰਫੇਸ। Sir, ਇਦਾਂ ਦਾ ਹੀ ਉਹੀ same concept ਹੈ?
It is the same concept, because whenever some integration is independent of the size of the body, then integrand itself has to be 0.
Okay, sir.
Let me try to clear it more. You see, by seeing this, a pure mathematical student, mathematics student will see it as indefinite integration. Okay, but in case of a physicist student, if it is not necessary to write the limits along with integration, if you have shown the diagram of the body, it means limits of the integration are known to you. So this kind of integration should be taken as definite integration, and constant of integration will not be there. Is it okay now?
Yes, sir.
Kindly keep this in mind. Now let us write its integral formula. Integral form. So it is very simple. Let me call this as equation number 4. Just take volume integration on both sides. del dot D will be equal to triple integration rho f dv. You know this quantity is going to become qf, and this quantity, if you apply Gauss divergence theorem in the backward order, apply Gauss divergence theorem.
ਸਰ ਉਹਦੀ ਡਿਫਰੈਂਸ਼ੀਏਸ਼ਨ ਕੀਤੀ ਹੈ ਤਾਂ ਇਹ ਆਇਆ ਰਿਜ਼ਲਟ
ਕਿਹੜੀ?
ਪਿਛਲੇ ਜਿਹੜਾ ਸੀਗਾ
This one?
ਨਹੀਂ ਸਰ ਨੈਕਸਟ ਪੇਜ ਨੈਕਸਟ ਹਾਂਜੀ ਆਈ
This
ਜਿਹੜਾ
one?
ਰਿਜ਼ਲਟ ਆਇਆ
हाँ, it is called differential form because del vector is a differential operator, beta. It is I cap curly by curly x plus j cap
जो कितने गई
है
ट्रिपल इंटीग्रेशन
integration. I did not get you.
सर ट्रिपल इंटीग्रेशन जो सीगी सर वो
हाँ?
किधर गई सर हट के में गई
Oh, I was talking about this only, ना बेटा. यही तो. I was saying this. Have you attended all my previous lectures?
यस सर सर मैम ਦਾ ਸਮਝ ਨਹੀਂ ਆਇਆ ਸੀਗਾ ਮੈਮ ਕਹਿੰਦੇ ਵੈਨਿਸ਼ ਹੋ ਗਿਆ
No. Even I have told about this. Now look at this. Please, should I take an example? Okay, please tell me. Integration of sine x dx. If I take the limits from 0 to pi by 2, please tell me what is the answer. 1. If I take the limits of same function from 0 to pi, what will be this answer? It will be 2. If I take the answer from 0 to 3 pi by 2, sine x dx, the answer will be 1. And if I take the integration 0 to 2 pi of sine x dx, the answer will be 0. Now same function is giving me different answer when I change the limits, and changing the limits means changing the boundary. Starting point, what is this? Starting point of integration. What is this? End point of integration. Let us say, yes, let us say if I am changing the size of the body, then my starting point and end point will be different. And if every time I have a function fx, I take its integration from limit a1 to a2, answer comes out to be 0. I take its integration from a1 to a3, answer again comes out to be 0. Now this is a mathematical if I take its integration from a1 to a4, whatever is a1 a2 a3 a4, let the answer again comes out to be 0. Now this
Means
condition
irrespective
is satisfied
limits.
only if fx itself is 0. Otherwise you cannot satisfy this condition. If the integration of a function is 0 over all the limits, then the function has to be 0.
ओके सर ओके आ गया समझ
Okay, now this is going to become qf. If I apply divergence theorem in the backward order, it will become double integration d dot ds is equal to 0. This is integral form of Gauss law for dielectrics. Now any other question? Any other question you can ask? Otherwise I will stop here. Is it okay for students?
ਸਰ ਉੱਥੇ ਡੀਵੀ ਵੀ ਆਊਗਾ
ਕਿੱਥੇ?
del dot d
Yes, very good. I request all of you to, whenever you find any difficulty, now this is the benefit of not muting you. Whenever you show good character, then you improve my teaching. Thank you, student. Whosoever, what is your name, dear?
ਸਰ ਅਨਮੋਲ ਮਿੱਤਲ
Anmol Mittal, thank you. This is the benefit of not muting you. Any other question? Should I stop here? Is it clear? Now I have completed my lecture. It was incomplete because of shortage of time in the previous
गॉस लॉ
lecture.
तो बाद की लिखी है
किथे?
तो
For dielectric. Gauss law for dielectrics.
पिछला पेज दिखा
ओके
लास्ट जस्ट एक्सप्लेन सर लास्ट स्टेप एक्सप्लेन करना प्लीज।
एक मिनट, कोई और बच्चा पहले बोल रहा है, वो बताए।
सर इंटीग्रेशन कोई फॉर्म जब आपने की उसके बाद जैसे लिखा ना गॉस डाइवर्जेंस थ्योरम के जो बॉक्स में लिखा है आपने, सर वो एक बार बताना कैसे हुआ।
गॉस डाइवर्जेंस थ्योरम हैव यू स्टडीड? For any vector A over a closed surface, its surface integration is always equal to volume
ओके
integration.
सर आई अंडरस्टैंड, यू हैव जस्ट अप्लाइड दैट देयर। ओके
I have, yes, 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 I have
you
applied
have just
that.
applied that, okay,
हाँ,
directly, okay sir,
I
thank
did
you।
not prove it. Some students were asking its proof when I discussed in my lecture, but I denied there because your mathematics teachers will prove it. I have to just use it. I have applied that. Any other question? Somebody was asking a question. If you do not have any question, I can stop this lecture for today.
सर जो हमने इंटीग्रल फॉर्म लगाई है वो ये फोर्थ इक्वेशन पे लगाई है कि जो पहले बनी थी वहां से लगाई है?
Fourth is integrated. I have integrated this equation 4. यहाँ पे I should write integrate. Let me write here. Integrate equation 4 over the volume of body. Then I will erase this, and here I will write then we get this. Is it okay now?
यस सर।
Any other question? एक लड़की कुछ क्वेश्चन पूछना चाहती है, प्लीज आस्क, otherwise I will stop. I am giving you time.
ਐਕਸਕਿਊਜ਼ ਮੀ ਸਰ।
Yes.
ਸਰ ਜਿਹੜਾ ਲਾਸਟ ਆਨਸਰ ਆਇਆ ਸਰ, ਉਹਦੀ ਜਿਹੜੀ ਨਾਰਮਲ ਫਾਰਮ ਸੀ, ਜਿੱਦਾਂ ਅਸੀਂ ਪਹਿਲਾਂ ਉਹਨੂੰ ਐਪਸਾਈਲਨ ਨਾਟ ਡਾਟ ਇਨਟੂ ਈ ਵੈਕਟਰ ਪਲੱਸ ਪੀ ਵੈਕਟਰ, ਉਹ ਨਹੀਂ ਲਿਖਣਾ ਸਰ ਇੱਥੇ ਕਿ ਦੇ ਰਹਿੰਦੇ ਨੇ?
ਕਿੱਥੇ?
ਸਰ ਜਿਹੜਾ ਲਾਸਟ ਜਿਹੜਾ ਆਨਸਰ ਲਿਖਿਆ ਡੀ ਵੈਕਟਰ ਡਾਟ ਡੀ ਐਸ ਵੈਕਟਰ ਇਕੁਅਲਸ ਟੂ ਕਿਊ ਐਫ।
हाँ, yes, 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 yes.
ਉਹਦੇ ਵਿੱਚ ਜਿਹੜੀ
You will stop. You will write in terms of d vector, not in terms of epsilon not e plus p.
ਓਕੇ ਸਰ।
Mute yourself. Any other question?
सर ट्रिपल इंटीग्रेशन कितना हटी दोबारा समझा दो एक बार।
हाँ जी सर, लास्ट स्टेप समझ नहीं आया।
ਕਿਹੜਾ ਜਿੱਥੇ ਇੱਥੇ?
हाँ जी सर।
ਨਹੀਂ
नहीं सर जिथे जिथे ट्रिपल इंटीग्रेशन हटी है पिछले पेज पे।
ਇੱਥੇ? From here?
यस सर।
Look at this. What is the answer of this integration?
0।
0. And let me go to the next page. I have told you that if the answer of integration of a function is 0 for all limits, then the function itself is a 0. It is a fundamental concept of mathematics. I have used that. Is it clear? I made a statement that this answer is applicable for all surfaces, whether these are small or large. It means the result is independent of limits of integration. Try to understand this. Small surface means closer limits of integration, and large surface means widely spaced limits of integration. Is it okay?
यस सर।
Okay.
लास्ट स्टेप दस दो सर।
Which one?
गोस्ट जेड़ा बॉक्स अंदर लिखे हो समझ नहीं आया।
This one?
हाँ जी।
ये तो इससे ही आ गया। डेल डॉट डी, ये देखो, ये गॉस डाइवर्जेंस थ्योरम लिखी है। डेल डॉट ए को ए डॉट डी ऐसे लिख सकते हैं हम, तो आई हैव रिटन डेल डॉट डी एज डी डॉट डी एस, एंड वॉल्यूम इंटीग्रेशन चेंजेस इनटू सरफेस इंटीग्रेशन. लुक एट दिस, वॉल्यूम इंटीग्रेशन चेंजेस इनटू सरफेस इंटीग्रेशन. ओके, एनी अदर क्वेश्चन?
सर थोड़ा बैक कर दो, एक पेज रह गया सी।
ओके
सर ये लेक्चर हमें YouTube पे भी मिल जाएगा ना सर, आपके चैनल पे?
हाँ, मैं अपलोड करूंगा। मैंने इसको लाइव नहीं किया क्योंकि मेरे घर में इंटरनेट स्टेबल है नहीं है, तो I will upload after closing this lecture. Okay.
थोड़े प्रीवियस
ओके
पेज
सर, ठीक है सर।
Okay.
और पीछे कर दो सर।
This one,
नहीं सर, थोड़ा और पीछे।
this one,
एस तो पीछे।
is it okay?
हाँ जी, आई सर।
Okay, you can note it down. Other students can leave this meeting. Thank you. Thanks a lot. If time allowed me, then I will take a lecture tomorrow also.